I'm going to give you 4 scenarios of finding the Cartesian equation for a parametric equation. So what is a parametric equation? It is an equation where I express x in terms of t and y in terms of t. And if the question is asking for a Cartesian equation, that means I only want x and y, no t to be involved. Okay, so here are 4 scenarios that you are going to do. Now in A levels, this very important identity, sine square plus cos square equals what? It's not given. You have to know at the back of your hand. Okay, since secondary school, we have done a lot of identities on this. Now, from sine square, how to get tangent square? See, here is sine square, how to get tangent square? Sine divided by cosine is tangent, so I divide by cosine square t throughout. I will get tangent square, cosine square divided by cosine square, 1 over cosine is secant. So remember, the c and the c cannot be together. So 1 over cosine is equals to secant. So 1 over cosine square is equals to secant square. Okay? The first skill to use if the question is asking for Cartesian equation. Sometimes the question did not ask for Cartesian equation, which I will talk about in the other videos. Okay? If the question is asking for Cartesian equation, scenario number 1, look for which equation that can make t the subject easier. So I look at this and I look at this. So obviously here I can make t equals to x plus 1. Okay, now I have this, I sub into the y. Y is equals to t is x plus 1, right? X plus 1 square plus 1. And this is the Cartesian equation already. Does it have any t? It doesn't have any t. And you must identify that what shape are we talking about this? This is a parabola, a U-shaped curve at negative 1, 1. So it is a U-shaped curve here. The minimum point is negative 1, 1. If you don't know this very well, this is actually your O-level knowledge that you have to know, a completed square. Okay, and then to find the y-intercept, let x equals to 0, and that would be 2. Okay, so this is the shape of this parametric equation. When you see cosine and sine, okay, the most important thing is to make sine and cosine the subject. So over here I have x minus 5 over 2 equals to cosine t, okay, making cosine t the subject, comma, y minus 3, bring the 3 over 3 equals to sine t. Okay, so I have to use the identity sine square t plus cos square t equals to 1. So I know that when I have sine and cosine, I have to use this identity. What is sine square t? And that would be y minus 3 over 3 bracket square plus cos square x plus minus 5 okay, over 2 square equals to 1. Now, in fact, it has already made nicely for you already. This conics. What is this conics? This is an ellipse. Okay, if you cannot identify that this is an ellipse, I may not have got the spelling correct, then please refer to the conics video on how to identify the ellipse. They already make one for you. And then what is the center? Equals to, so look at the x coordinate, look at here, the center is 5, comma, look at here, the y coordinate is 3, as well as what is the a? The a is the horizontal distance equals to 2, and then b equals to 3. Now be careful, because b is bigger than a, right? When you are going to draw the ellipse on your GC, you have to use you have to choose correctly which one to use. So now you come to your GC, I press apps, and then I press conics, and then I press ellipse. So you have to know that, okay, my a is 2, my b is 3. The b is the one that is below of the y, so which is this guy. Okay, if my b is bigger, then I know that it's going to be called a tall ellipse. The first one over here, okay, is called a fat ellipse. Basically, a must be bigger than b. Okay, but if the denominator of the y is bigger than the a, I have to choose the second one here, which is a tall ellipse. Okay, now I press enter. My a, what is a? The denominator of y, so it's 3, it's not 9. Okay, so it's 3, and my b is the denominator of the x, which is 2. My h is the 5, is the center, 5, and then the k is 3, and then when I press graph, there you go, it will look like an ellipse. But when you are going to sketch this now, this conics is the limitation of this conics is it only tells you the shape. You have to know where you are going to draw for it. So first, you need to have 5, 3, which is going to be here. So this is the center. You label this as 5, 3. You know that this is called the vertical distance. The distance from x is 2. So label this and put 2. Okay. The horizontal distance is the horizontal distance is 2, the vertical distance is 3. Usually they will trick you like this, because if it is 3, right, can you see, because this is the y coordinate and the vertical distance is 3, it is going to hit at touching this point over here, and this is how you are going to draw a conics, right? Okay, yeah. When you must identify not just the center, you must also identify the A and the B in order to draw a conics properly. Okay? Next would be involving tangent and secant. So if you cannot remember the formula that governs tangent and secant, I also always do this. Sine square t plus cos square t equals to 1. Okay? Divide by cosine square. Divide by cosine square t so that I can get tangent. Tangent square t plus 1 equals to secant square t. Okay, this is your starting position. Now, I make tangent t the subject. Tangent t equals to x plus 1, then over 3. Secant t is equals to y plus 1 over 2. By using the identity, I will have x plus 1 over 3 square plus 1 equals to y plus 1 over 2 square. In this case, 1 must always be the subject. So 1 is equals to y plus 1. Just now that question, right? You are supposed to open up the denominator over 4 minus x plus 1 square over 9. Okay, if you cannot identify these conics now, please go to the previous one to make sure you can identify that this is actually a hyperbola, and it's not just a hyperbola, it is a north-south hyperbola. Okay, north-south hyperbola, because the y square is positive minus the x square. So this is a hyperbola of center at -1, -1. So this is the center over here. You can just draw an asymptote right now, asymptote here, as well as an asymptote down here. Okay, the trick is you have to know that I need to find what is the asymptote. What are these two asymptotes? So the trick of finding asymptote for hyperbola and parabola is imagine the 1 to become equals to 0, because that is what we are trying to find, what happens when it goes to infinity. Okay, so this is over 4 is 2 square equals to x plus 1 square over 3 square. Remove all the squares, I have y plus 1 over 2 equals to plus minus x plus 1 over 3. Okay, so do some manipulation. Y plus 1 equals to 2 times of x plus 1 over 3. I will have y equals to 2x plus 2, 2x plus 5 over 3, bringing this 1 over here. Okay, then the other way will be y plus 1 equals to negative of 2x plus 1 over 3. I will get y equals to negative 2x minus 1 minus 3 minus 4 over 3, and these are my two. Okay, the upward one is 2x plus 5 over 3, the downward one is y equals to negative 2x minus 4 over 3. You can again use the conics to see how the shape is like. Going into your conics app, we are choosing a hyperbola. Okay, hyperbola. And then you must know that it is a north-south hyperbola. Can you see this is y square minus x square? Yeah, so this is a north-south hyperbola. My a is the denominator of the y. In this case, is a square. So a is 2 and not 4. Okay, b is 3. This is negative 1 because this is y minus k. We're having a y plus 1. So minus 1 for this and minus negative 1 for this. And I'm going to press graph. So it looks like this. When we are going to sketch this, I already know that my center is at negative 1, 1. So I need to know where does my graph cuts the axis. So it's going to be on top, on top of the y-axis. Sometimes it could be below. So that's why you need to sketch you need to sketch here to understand how does this look like. Yeah. Okay, the center is -1, -1, and then label the asymptote y and x-axis, label the graph, and you are done for these conics. Next is the most important, because many students are stuck in this, or when you see there's t plus something over t, it might not be 2, it might be 3, but basically this, the constant on top here and the constant on top here have to be the same. Okay, so the technique of doing this is you have to square both sides. X squared equals to t plus 2 over t squared. When you open this, this will become a squared plus 2ab plus b squared. Okay, and you realize that this guy over here, it will become a constant. So this will be t squared plus 4 over t squared. Same thing, do it for the y. Y squared equals to t minus 2 over t bracket square. Open it up, you have t squared minus 4 plus 4 over t squared. Okay, you will realize over here, t squared, this. They are exactly the same. And because this is a constant, right? So we can say that, oh, t squared plus 4 over t squared, I'm going to bring the 4 to the other side, is equals to x squared minus 4. Same thing for here, t squared plus 4 over t squared, bring the -4 to the other side, is equals to y squared plus 4. So these two, they are going to be exactly equal, because this and this, they're exactly the same. So what can I say? I can say that y squared plus 4 is equals to x squared minus 4. Okay, x squared minus 4. Okay, so now it depends. You have to see which one will make a positive constant. I bring the -4 here, so this will be 8 equals to x squared minus y squared. And then in this case, this again is, you have to divide by 8. 1 is equals to x squared over 8 minus y squared over 8. So this is a hyperbola. This is a east-west hyperbola. Okay, with a center 0, 0. Okay, and then the asymptote is y equals to x. Y equals to x. And y equals to -x. So east-west hyperbola is going to look like this and this. Okay, make sure it's symmetrical. Okay, and it's good to label the x-intercept. So x-intercept means when y is equals to 0, when y equals to 0, okay, I have x squared over 8 equals to 1. So x equals to plus minus square root 8. Okay, so this is -√8, and then this is √8. So this will become a hyperbola. Now, what I want to tell you is that sometimes the question can trick you, because what is missing from my question is usually the question will tell you what are the values of t to be over here. Okay, so for example, in this case, I didn't specify the values of t, and we are going to plot this, and it looks, there will be two sides. Okay, there will be two sides. Now, sometimes the question may give you t to be a certain specific value. I think a better example would be using something with regards to trigo. Yeah, okay, something like this. Okay, so if the question didn't ask for the Cartesian equation and ask you to draw the shape of the graph, so what you're going to do is to go to the parametric mode of your GC. Okay, you press mode, and then you will see here at the fourth function, there's function, parametric, polar, and sequence. Okay, so we press parametric, and that's enough. You can press y equals to, so you have to clear all this first. Okay, so you will realize that this is going to be in a parametric mode. Okay, now x1 is 3 tangent t. So when you press this guy, the x here, it will become a t. Okay, minus 1, as well as the other one will be 2. Now there's no secant function. Okay, so you own self have to alpha y to make it to be a fraction. 2 over cosine. Don't screw up this part. Okay, secant is 1 over cosine. T close, and then on the outside, then you press -1. Okay, you press enter. So when you press graph, right? When you press graph, it's not going to look very nice. That means something is wrong. So I go to mode again. It must be in radian. Okay, so that's done. And then you go to window. Okay, this is from 0. 3.14 is pi. Okay, 3.14 is pi. Now usually the question may ask you to sketch into 2 pi. So I'm going to change this to 2 pi. Okay, and then now I press the graph. I press zoom fit, okay, to fit the graph inside whatever I want to see. Not very good as well, so I press zoom standard for minus 10, 10, minus 10, 10, and you can see over here, in fact, very nicely, the question did draw a hyperbola with the two asymptotes for you already. Okay, so don't just key in the Cartesian equation, because number one, your Cartesian equation may be wrong. Okay, so always key in the original question, because the original question is always correct. Okay, and next I want to tell you is, okay, so if you need to draw from 0, always check your window. The t is from 0 to 2 pi, and then you are going to get 2 cycles. What I'm going to show you is sometimes the question may ask you to draw from 0 to pi only. So if I'm going to change this to pi, and then I press graph, you realize that the graph looks like this. Here and here only. So if you are going to draw from 0 to t to pi, it may look differently. Okay, it may look differently. Now I change the window again. So let's say I need to draw, the question asks you to draw from minus pi to pi. Okay, minus pi to pi, and then it's going to be back into 1 cycle. So this part is very important. When you are going to use the GC to draw the parametric equation, always make sure your window fits whatever the question is going to do for you. The window is always by default like 0 to pi or 0 to 2 pi. So remember to change your window when you are drawing a parametric equation. More so, I think I will talk about it in the next example. Okay.